This is Introduction to Limits, part 2 of 3 parts. We will learn to find limits from graphs. In order for a limit to exist, the right and left hand limits must be equal. And that's exactly what is being said here in this statement. The limit equals L if and only if both from the right and from the left are the same value, L. If they're not, we say the limit does not exist. So when you're doing limits from graphs, you're going to look at the graphs. We have 3 different examples here, all of which the limit exists. And it's good to do them from graphs so that you see the concept of limits being what y value is being approached. Now this first one, the graph is solid, continuous, and we're looking at the limit of f of x as x approaches 2. So if we look at where x is 2 and then go down to the graph, it looks like f of 2, the y value at 2, equals negative 2. So we could actually fill that in right away. The actual y value at 2 is negative 2. But to find the limit, we have to check, is the y value approaching the same thing left and right of x equals 2? So we look at the graph and we look from the left. As we go along the graph, when x equals 2, we're down at negative 2. And then also, we come from the right and we get to that exact same value. Therefore, the limit as x approaches 2 of f of x equals negative 2. Now look at our second example. In this one, we have an open dot or a hole at 3, 2, which we can read. We didn't have to be told that. We could read it on the graph. X equals 3, y equals 2. We have an open dot. So when we're finding the limit, that doesn't matter. We don't care if we have an open dot there. So we're just looking at x approaching 3 from the left. It's getting closer and closer to y equals 2. And then we go from the other side, the right, coming backwards, and it gets closer and closer to y equals 2. So the limit as x approaches 3 of f of x equals 2. And f of 3 does not exist. Now I know it's not equals does not exist, but we're not going to worry about that. We just write D and E does not exist because it is nowhere on the graph. But that doesn't mean that we can't have a limit there just because it's an open hole. In our third example, the limit also exists. We have our curve, well, we're looking at x approaching 1. So we're going to follow along our curve, always looking down at the x-axis to see what x is. Here it's negative 2, negative 1, 0, and going to 1. So from the left, it looks like y is approaching 3. And then if we come back from 4, 3, 2, it looks like y is still approaching 3. So our limit as x approaches 1 of f of x equals 3. And f of 1 is not there. We have an open dot there, but f of 1 itself is 2. So there are 3 examples that it doesn't matter whether the value is on the line, or if there's an open hole and there is no f of that value, or if the f of 1 in this case is a different value from the open hole. It doesn't matter every time the limit exists because you're only talking about what the limit is getting close to. Here we have 2 examples of limits that do not exist, and remember that will be because the left-hand limit and the right-hand limit are not equal. So let's look at the first graph. On this graph, we're going to be looking at x approaching negative 2, first from the left and then from the right. So on our graph, we'll go to the left of negative 2. X is negative 4 here, negative 3. And when we get to x equals negative 2, we see that the y value is negative 5. So we'll write that in as the limit of f of x from the left of negative 2. Then we'll go back and look at the right of negative 2, so we'll start at x equals 0, where here's x equals 0, x equals negative 1, and when we arrive at x equals negative 2, we see this graph is approaching y equals negative 1. Therefore, the limit as x approaches negative 2 does not exist. We do have a value for f equals negative 2. We have a value because we have a closed dot at negative 2, negative 5. Therefore, f of negative 2 equals negative 5. Now the next example shows you what happens when you have a vertical asymptote. Here we have a vertical asymptote at x equals 3, and we do have to test on either side of x equals 3 if we want to know the limit of 1 over x minus 3. So if you remember the table we had previously, on the left side, which would be x approaches 3 from the left, we were going downwards towards negative infinity. So the limit there would be negative infinity. Whereas from the right side, when we're coming from 5 and then x equals 4 towards x equals 3, we're going up to positive infinity, so that limit will be positive infinity. You don't have to write the plus, but just to show it, I'll write it here. Therefore, the limit does not exist because the left side and the right side are not equal. Now there are many times where you don't have a graph or are doing a non-calculator test where you can't have graphs or tables, so the part 3 for finding limits will be analyzing them with algebra.